What's up everyone? So from yesterday's video, we have found one solution for the cubic equation in general. So most of you already know that if we have a general cubic equation, which is a degree 3 polynomial, we are supposed to have 3 solutions in general, not just one. So today we're going to find out the other 2 solutions that we didn't figure out yesterday yet by picking up from what we left off. So yesterday we found one solution of the cubic equation, which says x is equal to negative b over 3a plus this term, right? The cube root of the quantity, negative q plus square root of the quantity q squared plus 4p cubed over 27 all over 2. And then plus the other term that looks similar to the first one, except instead of having a plus sign before the square root, we have a minus sign. And we also have some of the notations that we use, or we can say kind of like some quick substitution so that our expression doesn't look too long and too messy, which includes P and Q are actually in terms of A, B, C, and D, where A, B, C, and D are of course the coefficients of the cubic polynomial. And we also have the 2 terms U and V in lowercase, which are representing the first term and the second term. Now again, we can actually switch the order of U and V, it doesn't really matter, but just by the alphabetical order, let's call the first term with the cube root lowercase u, then for the other term we'll just call it V. We also have the following expressions: u cubed plus v cubed equals negative q. Also, u times v is equal to negative p over 3, as well as the substitution capital X equals lowercase x plus b over 3a. And again, the lowercase x is the original variable that we're solving for in our general cubic equation, and we just use a capital X in our substitution so that we can just make our general cubic equation into what we call the depressed cubic equation, meaning that there is no x squared term anymore. Okay, so enough of the recall. We're going to jump into the quick proof, or the quick derivation of finding the other 2 roots. Now, if you already have studied abstract algebra, especially group theory, ring theory, and also Galois theory, you perhaps already know that how we can get the other 2 solutions from the first solution that we have. But it is actually a little bit complicated to explain if you have never studied abstract algebra or anything such as group theory or ring theory or something even further. So today in our derivation, I will use high school algebra to actually get the other 2 solutions from the first solution that we already have. Here we go. Now, first of all, we still need to recall one more thing. From the original expression, we have a times x cubed. In here, we have the lowercase x plus bx squared plus cx plus d equals 0. And if you remember from yesterday's video, after we make it into a depressed cubic equation, we actually get the following. We have capital X cubed plus px plus q equals 0. So we're going to start with this, and we're going to play around the first solution that we have, so that we're going to do factorizing. How are we going to do that? Here we go. For the first solution, we're having lowercase x here. But in this expression we have capital X. So we're now going to substitute this equation, this relation right here, capital X equals lowercase x plus b over 3a, so that we actually get capital X is now equal to the negative b over 3a is going to cancel out with the positive b over 3a. So we end up with the two cube root terms. And again, we actually get u and v respectively by our substitution here. Next, before we throwing into this equation here, we're going to do the following. In this expression, we have x is in terms of u and v, but we can actually play around with it and make v in terms of u. How do we do it? Well, we can just use this fact right here. U times v is equal to negative p over 3. What does that mean? If we divide both sides by u, we get v is equal to negative p over 3u. So we can just substitute back in here such that we get x is equal to u minus p over 3u. Now keep in mind, this is the first solution. So we need to find the other two solutions. We cannot just simply substitute this into here because that will not give us any other solutions of capital X. But this is important. How do we know that this is always true? From the red part here, well, we can do a quick check. So we want to show that v, which is the second term, is actually equal to the following expression, negative p over 3u. So we can just check it here. We have v, which is radical, well, the cube root of negative q minus the square root of q squared plus 4p cubed over 27 over 2. So here we're going to multiply this with u over u, of course. It's a fancy one. Why? Because technically you can call it as how should I call it? Is the radical conjugates. So that when we multiply these two together, let's see what happened. And keep in mind, we need to divide by u when we multiply in, because we cannot change the value. So we need to keep this here. Now let's see. So if we multiply the v with u, we now get uv. And we already know that uv is actually equal to negative p over 3. But let's double check it. If we take the products of the two fractions, we have 4 in the denominator, 2 squared. And then for the first part, which is outside of the square roots, we have negative q times negative q, which is q squared. Good. And then we have plus here and minus here, meaning that we're going to use the difference of squares formula. So we get the first term squared minus the square of the second term, where the second term has a square root. So if we square it, we just get rid of the square roots and get q squared plus 4p cubed over 27. Excellent. So let's simplify it. If we distribute the negative sign, q squared and q squared will cancel out, and we will end up with negative 4p cubed over 27. So there's only one term in the numerator, so that we can cancel the 4 with the 4 on the bottom as well. And eventually we'll get negative p cubed over 27 inside of the cube root. And since it's a cube root, we can take the negative out, and then p cubed will turn into p. 27 is 3 cubed, so with the cube root, we will end up with 3 here. And then we will divide this whole thing by, again, this is what we call u. So we are going to divide this whole thing by u, meaning that we put the u in the denominator. So we just verify that v is actually equal to negative p over 3u. Okay. So now we can actually move on. Here, since we know that x in the depressed cubic equation, we know that x is supposed to have 3 solutions. And we already know one of the solution, which is u minus p over 3u. We can now try to factor it out into the following. We have x minus the quantity u minus p over 3u, which is our first solution of the depressed cubic equation. Then how do we get the other term? We can now use the long division, or we can take the shortcut. Since the other term is just a linear term, we can actually do the following. We will write down the roots here, and then on top, instead of writing the whole expression out, we'll just write the coefficients. So for x cubed term, the coefficient is 1. For the x squared term, the coefficient is 0. I'll just write here so that we won't forget, just like how we need to put the 0 in between numbers, such as 103, okay, 103. And then for the x term, we have the coefficient p, where the constant term is just q. So how do we do it? Well, we're going to do a quick trick here. For this version of long division, we can just simply pull down whatever we see from the top here. And then we're going to take this result and multiply with the roots that we have, and then add it with whatever we have in the original expression. So here we'll get 1 times u minus p over 3u, okay, which is of course u minus p over 3u. And then we're going to add it with whatever we start off, which is 0. So for the next term, we will get u minus p over 3u. Good. So for the next one, we will do the same thing. We now have u minus p over 3u times itself, which means we're going to square it. And then we need to add the p, which is from the original expression. So what do we get? Let's simplify it. We have u squared minus, now the square of a difference is going to give us negative 2ab. So we have 2 times a, which is u, times b, which is p over 3u. The u cancels out, so we end up with 2 times p over 3. So we have 2p over 3. Good. And then last but not least, we have the b squared, which gives us p squared over 9u squared. And then don't forget we have a plus p here. So this, we can just combine it with the middle term and tell us that we have u squared plus p over 3 plus p squared over 9u squared. Good. So here we get our constant term. And of course, we still need to double check whether we are going to get any remainders or not. But if we do that, we're going to multiply this result with the first roots that we have, and then we're going to add whatever we have in the original expression and see if we are going to get 0. So if we have this expression times the roots, notice that this is actually giving us the this is going to give us the sum of the cube. So with this provides us u cubed plus p cubed over 27u cubed. And next, we of course need to add q back. Now, be careful. It seems like we don't know what to do. We don't get 0, but we actually have one more expression that didn't use yet, which is right here. We also know that u cubed plus v cubed is equal to negative q, where v itself is actually up here, but we also have the expression up here, which is right here. So what does that mean? It means that if we have something if we pay attention carefully, we actually would get the following. We're now going to get this is equal to negative v cubed. Hold on. Did I do it right? Did I do it right? Excuse me. This one we need to be careful. When we take the products right here, we actually end up with the difference of cubes, not the sum of cubes. How do we know that? Well, we can actually check the last term. The constant term here is negative times positive will actually give us negative. There we go. So, it means that this expression is in fact equals to positive v cubed. Good. Why? Because now we have u cubed plus v cubed plus q. But from this expression up here, u cubed plus v cubed is actually equals to negative q, meaning here we get negative q plus positive q, which gives us 0 as the remainder. So here we actually have remainder 0. So we just verified it. We have factored out the expression. Now we get x squared plus this expression u minus p over 3u times capital X plus this expression here. So let me fix it. Plus u squared plus p over 3 plus p squared over 9u squared equals 0. Awesome. So since we already know the first result, which is from here, we are trying to find the other two results. And if we know that the first result is from here, we're now supposed to assume that this is not 0. So that we need to assume the other term is 0 in order to get the other two results. So we can now try to ignore the first one. Ignore it. And focus on the second factor, which sets x squared plus u minus p over 3u x plus u squared plus p over 3 plus p squared over 9u squared equals 0. So how do we do it? One way to do it is, of course, use the quadratic equation, the quadratic formula, and get the result, because it will always guarantee us that we will get the two solutions, no matter how arbitrary the coefficients are. But in that case, we probably would not end up with something nice or something that looked nice. So instead, we are going to do something that is similar to how we derive the quadratic formula, which is we're going to complete the square on the left hand side. So doing that means we have to consider this. In order to complete the square, here for the x squared term, the leading coefficient is 1. So if we try to make it into the following form, x plus or minus whatever quantity squared, we need to find out what the second term, which is the b term, is, as well as find out what 2ab is. So we say that the a term is just x. Then 2ab will be 2x times some b, which is equal to x, the x term here. That means we need to factor out a 2 from nowhere. So we need to multiply with 1/2 in order not to change the x term. So that we now get the b term that we need to complete the square. Great. So in order to complete the square, we also need the b square term. So let's figure out what b squared is. If we square this b term, we now have 4 in the denominator, or I can just put it at the beginning. And then we're going to square this term, which is u minus p over 3u squared, which gives us u squared. And then we have minus 2ab, so again, the u and u will cancel out. We end up with 2 times p over 3, which is 2p over 3. And then we have plus the last term squared, which gives us p squared over 9u squared. Excellent. So this is what we need on the left hand side. So now we need to move this to the right hand side and see how much we need to fill back in. So if we pay attention carefully, we originally have 1 whole u squared, but we only need 1/4 of it, meaning that we need to subtract 3/4 of u squared. Good. So next we have p over 3 here at the beginning, but now we need minus a quarter of 2p cubed. 2p over 3, which is the same as minus p over 6. So how much do we need to subtract? Well, we need to subtract p over 6 and then p over 3, which means we need to subtract half of a p in order to get to this result. Similarly, for the last one, we're going to subtract, and I'm going to leave it this way, 3 over 4 times p squared over 9u squared. Good. Meaning now the left hand side is a complete square. We can just write it as x plus 1/2 times u minus p over 3u quantity squared. How about the right hand side? Well, first thing we can see that they're all negative, so let's factor out the negative. Next, we have 3/4 in the first term and the last term. Let's factor out. So if we do that, what do we end up on the right hand side? We still have the u squared here. Then for the last term, it turns into p squared over 9u squared. Excellent. How about the middle term? Well, we can just think it this way. If we try to factor out the 3 over 4, we now need to multiply 4 over 3 back so that those two cancel out and get this value. So if we multiply p over 2 by 4/3, we get 2p over 3. And again, you can just quickly check it. Now, what can we do to this term? Luckily, the term on the right hand side is also a perfect square. And we can see that this is actually similar to this expression here. except instead of having a minus sign, we have a plus sign. So it actually gives us u plus p over 3u squared. So let's move to the next board and we're going to finish up the proof. Okay, so from the last board, we actually derived the solution, our equation down to this point. And now we're going to continue and finish up our derivation to find out the remaining two solutions of the general cubic equation. So how do we do that? And again, this is actually capital X. So to solve for capital X, we're now going to, again, we have square and square. So of course we need to get rid of the square by taking square root on both sides. And when we do that, just keep in mind, we only need to put plus or minus sign on one side of the equation. Because if we put it on both sides, we actually see that out of the four solutions, we actually get two pairs that are the same. So we actually end up with two repeated solutions that are actually not really repeated, but actually we're doing doing something that's unnecessary. So how do we do it? Well, if we take the square roots on the left hand side, of course we just end up with the term inside the brackets. If we take the square root on the right hand side, and don't forget we need to put a plus minus sign here, we are now going to get plus minus sign of the square roots of -3/4, and then times the square root of this, which is, again, we will get cancel with the square and leaving us with this expression. So now we need, of course, don't like to see negative inside the square root, and of course we can try to rationalize it, and we can just break it into square roots of -3 on top, or for some people they just like to use the imaginary unit I times radical 3 over radical 4, which is 2, like this. And again, just remember that this value right here is actually positive p over 3u is the same as v. So we can also substitute back in. We have x plus 1/2 of u plus v is equal to plus or minus I times radical 3 over 2 times the quantity u minus v. So last but not least, we're going to move this term here on the left hand side of the equation to the right hand side so that we can solve for capital X. So we get -1/2 of u plus v plus or minus I radical 3 over 2 times u minus v. And that is going to give us two things. Well, two solutions. First, we're going to get -1 plus I radical 3 over 2 times u. So we're now trying to combine the like terms in terms of u and v. So, and for the second one, we are going to get -1 plus what is it? I radical 3 times -1 minus I radical 3 over 2 times v, if we're going to take the positive root. So we can also put it like this if we combine the two roots together. But if we pay attention carefully, we can just split the two solutions separately, and we can try to find out something interesting as well. So let's call it, the plus sign is this. We are going to get -1 plus I radical 3 over 2 times u plus -1 minus I radical 3 over 2 times v, where the minus solution will provide us -1 minus I radical 3 over 2 times u plus -1 plus I radical 3 over 2 times v. So, what makes it so special about these two values? And we can actually see that we have -1 plus I radical 3 over 2 on the first in u for the plus solution, but then it appears in the v term in the minus solution, and then for the other one they just switch. What makes those two values so special? Well, here is the deal. This is in fact is equal to I times 2 pi over 3, and again this is actually related to something called complex analysis, and you can also rewrite this as cosine of 2 pi over 3 plus I sine of 2 pi over 3. And again, this expression, it is actually from complex analysis, and in complex world we can also mix it with the trigonometry part. But anyway, we have this here for the expression up here, and for the other term, -1 minus I radical 3 over 2. This is actually the same as this. We will change the angle from positive to negative to give us the value. Which is actually, in fact, the same as negative, well, I shouldn't say e to the I times 4 pi over 3 power. So in fact, what are these two values? They are actually called the primitive roots of the unity, meaning that if we're trying to take the cube root of 1 and consider the complex roots, these two are actually the complex solutions of positive 1. And in fact, we actually give them a variable called omega, which looks like a W, I know, but it is a Greek letter, omega. And here, this is actually equal to omega square, as we can see that this is actually square of this value. And of course, we can also say that omega cube, which is equal to this value to the third power, is actually equal to 1. And we see that it's actually giving us a cycle. And again, that is actually coming from part of the abstract algebra stuff. If you didn't learn it or don't know what I'm talking about, don't worry about it. But just keep in mind that we have the primitive roots of the unity that actually appeared in our solutions. So what does that do? That actually gives us the final result. If we consider capital X, and of course later on we'll move it back to lowercase x to finalize our solution. Capital X has three results. We have either u plus v, or we can have omega u plus omega squared v, or you can say 1 over, well, v, v over omega. So how should I put it? We actually get the following. We have omega times u plus v over omega to the k power. So again, k is any integer, and we can see that when k is k is a multiple of 3. In fact, we can just leave like this: 0, 1, or 2. If k is equal to 0, we just get the first solution, that x is equal to u plus v. And when k is equal to 1, we will actually get our first solution. When k is equal to 2, we actually get the second solution that we have, the minus solution. So that actually will complete our derivation. So let's finalize it, since we're trying to find lowercase x. This gives us lowercase x is equal to, again, we're using this very first expression to give us the result. Since capital X is lowercase x plus b over 3a, we can just move the b over 3a to the other side so that we can do a substitution. Lowercase x is equal to capital X minus b over 3a. And here will be our final result. Now we substitute in, we get lowercase x equals negative b over 3a plus omega to the k power times u plus v over omega to the k power, for k is 0, 1, or 2. And that is it. That is our general solution. Or we can just say that this is our cubic formula, a complete cubic formula for any general cubic equation. Now, last thing, you might actually ask, what if u and v are something such, what if u is equal to 0? Well, again, if u is equal to 0 in here, that actually means that we now need to be very careful. We need to pick what v is, and then we're going to take take here, and then we need to manipulate it a little bit so that we are not going to get something that is divided by 0 in our problem. Okay, but again, it shouldn't really matter, because if we have one of the terms is equal to 0, we still have the other term that is not 0 here, and in our expression we do not have something over 0 in the second or third term, so don't worry about it too much. And again, what if u and v are both 0? Well, if both u and v are 0, then it is even clearer. It means that we actually end up with a special case that the three solutions are actually the same. They're a repeated solution, and in fact it is a triple root, meaning that you will actually merge the three roots into one single point. Whew. So I know this video is very long, and it might be not too interesting for some of you, but I just want to share this and also try to use this result here so that we can just move back to the video on Monday, so that we can end up the solution of that video. If you think this video is cool, don't forget to like, and if you want to find out more of my videos, please subscribe to my channel, and also turn on the notification bell on the right hand side, so that whenever I have new videos, you won't miss it either. And if you have any thoughts, you can just leave your comment below. I will see you guys next time.